The next pollution we are starting right now is the water pollution. In the water pollution, we will discuss complete detail about the pollution status of the water and what are the different kind of things which are attached to the water pollution. And after completion of this water pollution, we will move ahead to the air pollution, which is one of the most important unit, not one of the, that is the directly the most important unit of this particular syllabus, because mostly the most number of the questions that you can find out would be highest, or that can be from the chapter of air pollution. So because in the air pollution, the good portion of the environmental chemistry is also included there. So because we have not discussed there in the chemistry, otherwise the things would be in repeated mode, so which we are not wasting the time here, which we are directly going on this air pollution chapter, and the good portion of the environmental chemistry would be completed also there. So here, before going to that, we have to complete the water pollution chapter. If you look at the past year's paper, average number of questions that you can find out, that would be in the range of 4 to 10. So almost, if you look at the average number, almost you are going to get 7 questions from the water pollution chapter in each year's paper. So that is again a very important unit, because a good number of questions are coming from this water pollution chapter. So let's start the water pollution. So as of all of you know that what is the water pollution. So water pollution is addition or over addition of any kind of factor, any kind of impurity, any kind of biological thing, any kind of physical thing, or any kind of chemical thing in the water. So that particular water is now unfit for use by the organisms or including the human beings. So we say that the water is now polluted, and that causing agent, which may be the factor or biological or chemical or physical agent, that is called as the water pollutant. So here the factor, why I am saying factor, because suppose you are adding only heat to the water, you are not just you are not adding any kind of, suppose there what we can say, any kind of impurity there, maybe physical or chemical or biological, but still you are adding a factor which is increasing the temperature of the water. So that is also part of the water pollution. That's why it is very important to use the factor in the definition of the water pollution, or maybe in the air pollution as well, because the thermal pollution is also type of pollution, or increasing decreasing the characters of any kind of character in the water or air is also kind of pollution. So now, if you look at the water pollution can be divided in two main types. So what are these two main types? The two main types that you can see here, one is the point source, another one is the non-point source. So what is the point source of pollution? So here, if you look at this particular image, these are the example of point source of the pollution, where we know exactly that from where the pollution is coming from. Maybe from this particular pipe, maybe from this particular pipe which is coming out from a single factory, or maybe a single house. So that is kind of point source of the water pollution. Then we have the non-point source as well. In the non-point source, the water which is coming and which is polluted, that is coming from multiple sources. For example, agricultural field. In agricultural field, you cannot track from where the pollution is coming. That can be coming from any of the field, and that kind of pollution can be termed as non-point source, because we don't know the exact source of the pollution. It is coming from a larger area, so that would be your non-point source of the water pollution. The point source examples are the sewage pollution or oxygen depleting pollutants, which is mainly containing of the organic compounds. Then we have the industrial or heavy water pollution. Then we have the marine pollution also, that is also coming from the shore area or maybe beach area. Again, a single source here. Non-point source examples are the agricultural field, that is nutrition pollution, you can see, or nutrient pollution. That excess amount of nutrient which is used in the agriculture will go away with the runoff water. Then we have non-point source of example of the groundwater pollution. If suppose entire groundwater is polluted, so we again, the pollution is done by the entire area, not by any one source or single point. Then we have the oil mills as well. Oil mills also, discharge their effluents or the pollutants in the multiple sources or in the multiple locations. So again, that is example of the non-point source of the water pollution. This is the very first basic thing about the water pollution, the types of water pollution, point source and non-point source. So I hope it is clear to you. If you look at this particular image as well, so here you can see this is the development or OSDS area. This is the city. Here you can see this is one kind of factory or one kind of oil vessel which was taking the oil, and now oil is leaked due to some kind of accident. So here this is kind of point sources. And suppose if it is coming from a larger area, from the city, from maybe developmental areas, maybe from the farms. So these all are the non-point source. Similarly, roads are also kind of non-point source of the water pollution causing agent. So this is the difference between the point source and non-point source type of water pollution. So if you look at the different types of water pollution, the most important or critical water pollutant is the sewage pollution, or you can say the household pollution, because the amount which is coming from the sewage area or from the household, that is very, very huge. And that is mainly containing all the organic impurities. And this organic impurity, when reached the water, then it will contaminate the water at last, and there would be a problem. So the sewage is the term used for the wastewater that often contains the feces, the urine, and the laundry waste, which is coming from all the households. The sewage disposal is a major problem in developing countries, as many people in these areas don't have access to the sanitary conditions as well as in the clean water. So here, few parameters we have to use to determine the water quality with organic effluent. So the parameters which are very widely used worldwide, that is the DO, dissolved oxygen, BOD, biological oxygen demand, and COD, chemical oxygen demand. So let's see these characters one by one, starting with the DO. So what is the DO? DO is the dissolved oxygen. So dissolved oxygen, the meaning of the word itself, you can, this is telling you the amount of oxygen which is currently dissolved in the water or present in the water. The ideal range of the dissolved oxygen in the water is 8 milligram of the oxygen. At least there should be presence of it in 1 liter of total amount of water. If it is less than 8 milligram per liter, then water can be called as contaminated water. And if it is going down by 4 milligram per liter, so that water is totally polluted water, nothing is left. And here, this particular graph you can see in this dissolved oxygen slide, it is telling you the dissolved oxygen level during the different times of the day and night. So here you can see this diurnal fluctuation. This is called as diurnal DO fluctuation because it is showing you the day and time graph. So here you can see during the evening time, the highest amount of dissolved oxygen you can find out in the any ocean or lake or maybe any water source. But here the reason behind this was the photosynthesis. So after the 6 p.m., the photosynthesis cannot take place because of the sunlight. So automatically the dissolved oxygen level will go down. So from the 10, it can come down to the 6. And again, when there would be noon time after the 6 or 12 or maybe 6, so again this value will go high due to the available photosynthesis. And this diurnal process in the water body is continuous. So during the respiration dominates, during the dark night the value would be low. During the daylight, the photosynthesis dominates the other processes, and this will increase the total DO volume in the water. Then we have the midnight dark. So this is also respiration dominates here, and there would be no oxygen available. And similarly, again, the next day, the same formula will take place, or the same phenomena will take place. So this is called as the diurnal dissolved oxygen fluctuation. So I hope this particular graph is clear to you. So one by one, we have to see the factors which can affect the dissolved oxygen level in the water. So very first factor here is the temperature. If temperature increases, so the mobility of the gases increase. The oxygen will go out from the water. So here, if you are increasing the temperature, the dissolved oxygen level will go down. And if you are decreasing the temperature, the dissolved oxygen level will go up. because both are inversely relatable. So DO is inversely proportional to 1 by temperature, sorry, inversely proportional to temperature only. But DO, dissolved oxygen, high during the summer time. So this exception is important to you. Why? Because during summer time, high amount of sunlight is available. And if high amount of sunlight is available, larger would be the photosynthesis amount. If larger would be the photosynthesis amount, then on that scenario, the DO will also go high and high. So this is the factor, first and a very important factor which can affect dissolved oxygen. The next thing is the Henry's law. So Henry's laws in the gas law, which says that the amount of gas that is dissolved in liquid is directly proportional to the partial pressure of that gas above the liquid when the temperature is kept constant. So that we have already seen in the previous classes as well. So this is the partial pressure P is directly proportional to C or directly proportional to P, you can say. That is the dissolveness, you can say P, and here this particular P, the partial pressure, that is equals to KHC. So KH here is a kind of constant which was introduced here by replacing that proportional value here. So here the solubility of the gas is directly proportional to that partial pressure of that particular gas above the liquid surface. The next factor here that can affect the solution of the dissolved oxygen is altitude. With increasing altitude, the always the DO will reduce, and the reason behind that is very simple, because by the increasing height in the Earth's surface also reduces the amount of oxygen present in atmosphere. So it is very obvious that the dissolved oxygen would be also go low and low with the increasing height in the Earth's surface. So that was all about the dissolved oxygen. The next thing we have to start is the biological oxygen demand. So biological oxygen demand is what? The biological oxygen demand is the demand of oxygen which is created by the microorganisms present in the water to dissolve or to degrade all the organic matter present in it. So amount of oxygen required for the microorganisms to decompose or organic matter present in it. So here the biological oxygen demand is inversely proportional to the DO. So dissolved oxygen higher, so lower would be the biological oxygen demand. If dissolved oxygen is lower, then the higher would be the biological oxygen demand. And this BOD is also divided in two different types. One is called as carbonaceous BOD, another one is called as nitrogenous BOD. So carbonaceous BOD would be the amount of O2 oxygen required for organic matter conversion. So here organic matter plus O2 will create CO2 plus H2. Then we have nitrogenous BOD, so amount of O2 required for ammonia conversion. So that would be the nitrogenous BOD. So here NH4 plus O2 oxygen that is converting into nitrate. So this is the ammonium conversion, and that is called as the nitrogenous BOD. So in Indian standard, BOD5 is used. What is the meaning of BOD5 here? BOD5 means the biological oxygen demand of total 5 days. That is BOD5. BOD5 is not total BOD, because if you look at the total amount of organic matter, it can take up to the 3 to 4 weeks, up to the 1 month of time to degrade all the material present in it. So on that scenario, if you are taking multiple samples, suppose maybe 50 samples or 100 samples daily, and this would be very hard to maintain all the BOD calculation, and by waiting 30 days, 35 days, so there would be lots of the time waste. So reduce that, we use the BOD5 only, which can calculate the BOD for 5 days only, and that would be the carbonaceous BOD only. So standard temperature of the incubator to determine the BOD5, that should be 20 degrees Celsius. So I hope this particular slide is clear to you.